Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, welcome everybody. Okay, we would like to welcome you to this new program. Okay, new interview program. So basically, my name is Zaki Yamani Zakaria. I'm previously a practicing chemical engineer and now I am an academician. Okay, I'll be handling and conducting several interview session with practicing chemical engineers, so all of us can learn from each other. Okay, so with me today is one very special person. He's actually a practicing engineer working with a petrochemical company in Johor. His name is Haseeb. Okay, we are very fortunate to have Haseeb here today. So welcome Haseeb, how are you doing? So Haseeb, I'll be asking you several questions. So we just want to share information, share experiences, share aspiration, fellow junior chemical engineers or students out there. All right, so let's begin. Okay, so if you don't mind, okay, can you please state your full name?
My name is Abdul Haseeb bin Saleh. So I'm born in 93, so that means I'm 28 years old this year.
Oh, okay, 28 years old. Okay, fantastic. How long have you been working as practicing engineer?
Practicing engineer ever since my graduation on the when I was 23. So that means from 24 onward to now 28 is around 4.5 years.
Oh, okay, wonderful. 4.5 years. All right, that's good. Where did you earn your bachelor chemical engineering degree from?
I earned it from uITM Shah Alam.
Okay, Universiti Teknologi MARA, Shah Alam. In chemical engineering. Okay, all right, fantastic. So are you actually currently affiliated with any professional membership under engineering or anything?
Affiliated with two, which is one is the Board of Engineers Malaysia and another one is the Institute of Engineers Malaysia.
Okay, all right, fantastic. So those are the basic ones for chemical engineers in Malaysia, right? Okay, good.
Yes.
Okay, this is a little bit maybe funny. Okay, maybe you have your favorite subjects when you were studying back there in uITM Shah Alam?
Initially, when we start our chemical engineering degree, the subject is more to the core of the chemical processes. That means we start with the organic chemistry, the thermodynamic, everything. So, initially, in the beginning stage, my favorite subject was the mass and energy balance. It's like why I like it so much is like every time we were given the question, and then when we see the question, we see the whole process in one side, and then we can tell, we know the objective is whatever is the input must be equal to what is the output. So the tricky part is in the middle. So it's like a puzzle for me. It's like finding a puzzle. Oh, where could this one go? Where could this one go? So we know the objective, we know the in, we know the out. The missing part is so. Why I like the subject is like whenever I see the subject, it's like I have a clear picture of what I need to do. I just need to find how to look for the problem, how to look for the solution. And then throughout my second year, third year, then that time my favorite subject start to move towards the economical side, which is the process plant economics. So that time it's teaching us to be a business. It gives you the big picture. It's like everything we do as a chemical engineer, there's a reason, and the reason is always number one, the economics. How are you going to make it profitable? How can you reduce cost? That's why all our process improvement, all process innovation that have been going on is always for one thing, the economics of the process. And then that's a second subject, and then third subject is the last subject that it was in my final year, which is the petrochemical process. So the petrochemical process is like because we as a chemical engineering student, before we even start our chemical engineering, so we always adore those oil and gas. Everyone, I think most of us wants target is oil and gas. So like when we learn the petrochemical process, like we actually learn what we want to, what our dream is. How we get to learn it before we start our job. So those three.
Okay, so you have three favorite chemical engineering subjects. So the first one was mass balance, mass and energy balance, mass balance. Okay, second one, maybe it sounded like engineering economics.
Yes, maybe.
Okay, and then the last one is petrochemical technology, something like that, right? All right, okay, fantastic. Okay, Interesting. Okay, now that we know a little bit about you, maybe can we know what is actually your present job, your present occupation?
My present job, now currently I'm working in Lotte Chemical Titan in Pasir Gudang. So as a production engineer,
Oh,
I'm working in the operation department under the cogeneration utility and cogeneration department operation. So my title is actually as a production engineer or operation engineer, as I may call it.
okay. Production engineer, but you are handling utility.
Yes, production engineer handling utility and cogeneration processes.
Okay, because normally production engineer, based on my understanding and experience, they handle certain product. It seems that what your present position, from my experience and knowledge, it's something like utility engineer or maybe maintenance engineer, but in your place it's called production engineer.
Yes, in our place, they assign it as like there's a operation department, maintenance department, and then there's a supporting, which is the maintenance, the instrument, the electrical. So under those operation department, all the engineers are called the production engineer.
Oh, okay, okay, okay.
From a process engineer. Process engineer is under technical department, handling the technicalities of the process. The production engineer is actually operating the process.
Okay, all right. So you are now, your title is actually production engineer, handling some utilities and also cogen plant.
Yes.
All right, okay. Can you just share with us what are the subjects, the subjects that you learned before that are related to what you are currently working on right now?
I think most of it.
Most of it.
We just sharing, just like when we are student, there's always a saying that whatever you learn here, you won't apply it in your work area. There's always a saying, but then that's not exactly true. It's just that if you don't look for it, you will not find it. Just like every process, it's like, okay, you're doing A to B. Okay, that's a very, very basic. A to B. But then why did A goes to B? That's when you start to go to the first layer. The first layer, you see like, oh, this is due to this reaction, blah, 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 blah. That goes to B. And then you go for the second layer. Why did this reaction happen? Then you start to find the thermodynamics behind it. It's always due to this reaction. And then when you goes to the third layer, will start like, oh, because then you start to go to the property of the material itself. It is like, oh, because of this chemical bond in this direction, which is affecting the polarity of the bond, is affecting this. So that's actually, you already learned that in your university. It's just that if you look from the big picture, you will not find it. Just to get out of my mind. So when I'm doing my work now as a utility and cogeneration process, so utility, the main process of the utility is actually to supply the steam. That means they call it the heart of the plant is always the boiler. So the boiler is producing the steam, and then we are utilizing the steam to operate the equipment. So as a first, when we now I'm a production engineer, my main product is the steam, and then the pure water. So the steam, when we talk about steam, we deal first and foremost is the thermodynamics. So thermodynamics, and then and most important in the thermodynamics is the steam table. So we have a multiple grade of steam, and then all the steam table has to be in our mind. Oh, this steam quality should be this. This steam should be at this temperature, how much, and then this energy should be how much. We whatever cost related to steam, like how many USD per megajoule that you produce, is always, we already have that.
Yeah, simply like you can estimate that if you want to have temperature like 250 degrees Celsius, we need to have like 60 bar pressure.
So just like oh, how much you need this steam? Oh, by my experience, I have done few calculations. So you need at least this pipe size. And then when I start when I go walk around the plant, and then I see a steam leaking. With that amount of flow, I know how much loss I'm making per hour based on that leakage. So we have that in our mind. So that is the first, is the thermodynamics. Second is, of course, the mass balance. So mass balance is how, let's say in the boiler, how much gas I need, how much air I need, and then air to fuel ratio, I need to mix it to get this ratio, and then how much water do I need to convert to the steam, and then blow down everything. So in the end, that's how it will be balanced. And if it's not balanced, then there's a few reasons. Where that is where the troubleshooting part come in. If the imbalance is within less than 1%, then it could be an instrumentation error. But then if it's more than that, then that's when we start to identify where can the steam loss be, where is it missing. Then we go around the plant, see, oh, it's missing here, and take an action, solve the problem. And then third subject is the fluid mechanic. Fluid mechanic, because we, even though we mostly we are production engineer, so production engineer by right is you operate the plant, you leave the technicalities to the process engineers. But then if you simply operate the plant without knowing what you are doing, you are not going to improve. So the production engineer, they have to stand up, not to say stand above the others, but the production engineer, you have to be flexible. You have to know in details the technical. You have to know the instrumentation. You have to know the mechanical. So it's like if you see a problem, you are a production engineer, you see this pump is having a problem. So rather than simply reporting to the maintenance engineer, I have this problem, you can go above one step and tell, oh, this problem is because of this thing. It's happening because maybe the operating condition is not, or something is happening, or like the seal clearance is not. So you have to have that skill.
Yeah,
You
mechanical seal problem or airlock problem or lack of power problem, strainer problem.
instrumentation, you see this analyzer always issue. You run 1 hour issue again. So it cannot be like the instrumentation is a problem. It could be your process problem. Why the process problem? You see the tube design. Oh, wonder is have a pension. That means water is accumulating inside. You are not bleeding it. So you bleeding it, your problem solved. So rather than call the instrumentation engineer, oh, wait for 1 day or 2 days before the solve. If you have the knowledge, you can solve it immediately on site. So being a production engineer, you have to be flexible. You have to know the operation, you have to know the technical, you have to know the instrument, maintenance. So when getting on to the fluid mechanic part, so by fluid mechanic is more to the process design. So it's like when you're dealing with fluid mechanic, and then you will be assigned a few projects. So one of the future project is like, okay, you have to identify, you have to build a pipe from A to B, and then that's a pipe. So you have to do your pressure drop calculation. You have to study your head loss. Is this pipe sufficient? Is this sizing sufficient? So those are what we have to deal with weekly. I say weekly or bi-weekly. We have to see the pressure drop. If like, oh, this medium at this pipe, by right, if it's a clean service pipe, you should know the pressure drop should exceed 0.2, should not exceed that. But then it's actually 0.6, or there must be a restriction somewhere. So you can have a line walk, see the problem, identify the problem at site. So your main as a producer is always solve the problem, make it smooth.
Okay, so you have answered quite very long. Okay, so it's interesting that you relate the thermodynamic, the mass balance just now, and also the fluid mechanics, and then you mentioned a little bit just now at the end process design. So, but basically, I think you will need more than those subjects, right? To help you run your work.
If we
Okay,
more
run your
more related subject, like I'm dealing with water now, I actually dealing with the organic chemistries, the water, the bond, and then suddenly we see again the van der Waals bond, hydrogen. Start to see all those.
It seems like you enjoy your job very much now, from the way you explain. So that's very nice to know. But can we just know what aspect do you really enjoy about your work at the moment?
The challenge, the mystery, and then the challenge is tough. It's going to be tough, But then the sweet part is when you actually solve the problem. It's very thrilling. I can say it's like when you solve one small problem, it builds up your confidence. And then when you start to see a bigger problem, you start to like, okay, maybe you can try and solve this problem, and then you're able to solve the problem, and then it boosts your confidence even more. So
Yeah, I
now,
believe confidence is one thing, and then your sense of satisfaction is another thing.
and then it's like when I start my job, we always have something in mind. Just like by the time when we are juniors, we always have that, oh, if this problem is, it could be like that. But then we as a junior, we are not confident to voice out our idea. So it's like, oh, this guy don't know anything, simply say something. It's like that. Then you leave it more to your seniors to handle the job. But then it's like when the seniors solve the problem the way that how you thought it would be, and then you start to feel like, oh, actually my logic is quite makes sense. I can actually solve it also. And then you start to try like think out of the box, try to give try to pour out an idea, see if it works. And that's the most enjoyable part of my job. I miss the thrill in solving the problem.
Okay, the thrill in solving the problem, you become very satisfied, and then you become very happy. All right.
Very
Okay, that's good. Okay, move on to the next question. Anything that you feel you can improve about your work, about your job?
There's a lot to improve in my works, especially in design wise. So it's like as a production engineer, I'm exposed to the troubleshooting every day. But then when I see something at certain equipment is designed like this, so I always wonder why it was designed like that. What design consideration is being think of to have to propose such a design. So that kind of part is what I'm searching for. I want to learn how to design.
Okay, so the design part, maybe during our time as a chemical engineering student, we did not cover the design part very much, right? So normally the mechanical engineers do that.
And then we were given the version, and then we were taught to follow how they do, but we never understand the logic behind why they do it.
Okay, next question. What is the most challenging moment ever happened when for the past 4.5 years working? The most challenging one only, okay?
I think you know this one is it was during my, I think my first 6 months starting my job in Lotte Chemical Titan. So that time there's a very big plant issue, which is the condensate loss problem. Utility engineer, we handle the steam, and then the steam is always recovered as a condensate. It condense, and we call it the condensate, and then we recycle it because we are not throwing away the money, the energy that we spend. We always recycle it so that the plant is in its most economical operating state. So when the condensate loss and you are unable to recover it, so that is a very huge loss to the plant. So it's like amounting to 6 million per year. So that time is because this is such a huge amount. The priority is very high, and we were like, you are assigned into this team, you must solve the problem. Every day you have to report your progress, because it's a big issue. Nobody wants to lose 6 million every year, and then the money that you lose every year is a few thousands, 10 ribu per hour per day. So this is the stress given by the top management. They always push you. What is your progress today? When can you solve? What is your solution? Why you haven't identified? So that is for me very difficult moment. Just like I mentioned, I'm just starting the job. I have my seniors with me to guide me, of course. But then I have what I think is this should be the solution, but I'm not confident yet. So that was the time when me and my seniors we try to solve. We start to see, we do the mapping, we trace back everything, check back the steam table, check everything. Oh, this doesn't match, it should be this problem, we should pinpoint this. Then we check each stage. Oh, we identified, oh yes, we actually there's a clue for this. Why why this was problem. So when we start, and then the progress will be like, it's like slow and then like, oh, like that. So it's not like we have a steady progress. No, it's like everything is blur for you. When you have a big clear picture, you start to blur out, and then we think we know what is the problem. Then it's like where we need to say, oh, if we validate our own theory. So it's like, oh, and then in the end
Then it becomes exponential solution, right?
it's like, oh, the more you spend time to it, the more it gives you the idea, the more you have a clearer picture of what is happening. And then when you done the problem, solving the problem, that skills that you earn while doing the problem, we call it the experience. That experience, it gives you, it's like whenever you look at different processes, you always start to think back how you solve the problem. The way I solve it is that I see the big picture, which part, like the mass balance, which part did not match up. And then when I see the problem, I always we have our thought process. How are you going to solve the problem? So that thought process is the skills that you earn, and it's going to help you in the long run.
Okay, so it's the condensate issue,
Yes.
and you are part of the utility team, and you need to solve that. Yes, I understand. So the condensate contains a lot of energy, and it's going to be a waste of money if we just release it just like that to the drain, to monsoon drain, or to anywhere, right? So you want to recover as much as possible. Okay. Okay, here comes the next question. Okay, can you please describe what is your typical day at work? Your typical day at work. Okay.
The typical day of work would be we monitor our daily production, what we producing yesterday, how much we produced. Okay, it's like normally things are not going to change much because like optimally your plant is going to run at their full load, and then at this full load you will have your specific utility consumption. So you will see like, oh, you're producing this team, how much this team, and just like, okay, you are just keeping track of it. That will be your typical day at work. And then another thing is you will be assigned a project. Like we have a few projects in hand currently, so you will progress your project. But then the learning will be every time you progress the project, you will learn something new. You will learn, you will make decision, and then you will see how your decision impact the progress of the project. Is it a good thing? Is bad thing? How can you learn from it? So that will be the typical day at work lah.
So you monitor, and then there are certain projects that you need to do. Do you need to write any report?
Because we in my company, there's we as an operation engineer, we were split into the shift team and the normal management team. So the shift team will be totally operation only. He will take care of operation everything, and then he will do the report. I'm in the management team. Yes, so we will evaluate the report, see the condition, and then if it's okay, then we progress our project, and then we just report. If need to be, then we will report to the higher management. This is our production, because like shift team will provide the info to the normal operation team, and then the normal shift team will report to the top management.
On a typical day, what time do you arrive at your workplace, and what time do you leave?
My official working hour in my company is 8:30 to 5:30. So typically I arrive 7:30 in the morning.
At a typical day, a normal typical day, do you feel stressed? Okay, so normally everything will be smooth, everything will be okay. So you are happy working, right? Okay, now go to the next segment. Okay, what will be your how would your non-typical day at work looks like?
Non-typical day is there's two type of non-typical day. One is the planned and the unplanned one.
Okay.
So the planned one is like, okay, you know you're going to commission your system next week, or you're going to start the next. So the planned one will be you will have done your preparation, so that at the actual non-typical day you have many uncertainties, but then the major one should be already in the plan. Okay, this problem I have this prepared for this. It's like like I know tomorrow I have to start the steam system. So today I will have done my preparation, tomorrow actually the problem will be like, oh, why is this guy missing? Why haven't he opened yet? He's supposed to start at 8. So then this will be another thing, but it will be a small issue. If it's already been planned, then normally it will go smooth. The unplanned one is where the stress part come in. The unplanned one is when you are doing your work, suddenly you see the boom. It can happen. And then just example, one of my day going will be like I was cycling, and then suddenly I heard an explosion. So it was like my boiler fan flying.
Oh my god, your boiler fan. Your boiler fan or your cooling tower fan?
Yes, the forced draft fan flying.
Okay.
It's a first occurrence. Okay,
Oh my god.
so what have done at the time is it already become an urgent situation.
Yes.
Because our plan before that is one boiler shutdown. That's a lot of impact to the process plant because our steam is mass balance. Steam produced is for this process. So now your steam production reduced. The process production will reduce. And then if you want to catch up, you have to take extra step A, B, C, this boiler load up, boiler load down, this boiler shift, water shift from here, start the system. So when you have enough experience in your own process, whenever one process is affected, you have the clear picture. If this is being affected, it should cover this process. It's like that. But then let's say another typical work is like there's a dangerous occurrence part, and then another thing is when you are doing the troubleshooting. So troubleshooting, you like you go to the site, you will have to like crack your brain. How are you going to solve the problem? So just sharing like one of my typical days. It was I think my first 2 weeks starting my job in Titan. So that time my senior manager, he challenged me. So it's just like he wants to see how I work. So he put an unnecessary stress. He said, I want this system. What problem if I going to elaborate more is like we have a small instrumentation pit. So what happened is like when it's being built, every time it's rain, the instrumentation pit will get filled with water, or the instrumentation will throw error, showing zero, reading error. So what they do is they install a small pump. So install a small pump to pump out the water, but then the small pump, and then due to the lack of air, is actually causing trouble at the other plant. So he wants me to solve the problem, get the problem done, but solve it in my own way. Then I just like okay, I just find out here. It's just like he asked me to do this, but then for me that time it's just like I don't think his solution is very good. So I just say that, boss, I don't quite agree with your solution because you are causing a lot more harm to this site just to get this thing done. So like that time he got angry with me. Wow, you only 2 weeks, but then you get to fight me to that girl. Then he scold me. Then I just tell him, boss, you give me 1 day. If I can find a better solution, I give to you. Because you rejecting you because I have another thing I plan in my mind, but you turn me down because you don't know what else I'm thinking. If I can do a better job than what you propose. So the next thing was that I do what he want, but in a different way. I take the source from something else. I modified something else to get what he done, but without the side effect that will pick up by his solution. So the next day is I propose to this, and he's just like, oh, okay. Then that moment he said, from now on, whatever problem, I will only tell you the problem. I want you to find the solution. I won't advise you because I judgment.
Okay, that's a good experience, and then you have shown your superior that you are really a reliable person to solve the problem. So that's good. Well done.
I will not be a yes man. I will not say like, oh yes, I will do. Then I'm not doing the thinking. Then there's no value in me as an engineer.
Yes, agree. Okay, so we have covered some backgrounds, some typical day at work, some non-typical day at work. So I think we are going to move to the final segment. Okay, so you have worked for 4.5 years roughly. So what will be your next plan after this? Maybe you have some wonderful planning or strategic planning about your career, about your work. So what will it be if you want to share?
Plan my career just like now I'm a utility engineer. I'm dealing with water and steam. So in that field, there's actually a lot of competency involved, especially with the commerce area. So now I already took my steam engineer examination. Hopefully I passed the examination.
Steam engineer 1 or 2?
Grade 2 first.
Grade 2, okay.
So I already took the exam. Now waiting for the result. Hopefully I pass. After that, my next time will be to take the internal combustion engine competency, which is for the gas turbine.
Okay.
So that plan to go for training end of this year, and then by next year I should attend the exam already. And then third is my mentorship with you. To become
okay, hopefully you can be a professional engineer very, very soon, okay?
It's
Alright.
It's a dream since I was a student.
Yeah, inshallah. You can. You're a very good engineer. Okay. Okay. Next question. Okay. Knowing you since the past year has been quite interesting because when I read your report, wow, this guy is doing a very, very organized and detailed report. So I was quite amazed with the quality and standard of your report. So I believe that is actually being backbone by certain philosophical principle that maybe you have within yourself. So maybe you can share what is your maybe your life principle or philosophy or whatever.
Okay. Actually, I was I'm not saying I'm good now, but I was not as good as I was now when I was a student. So what inspires me that time is actually my supervisor during my internship. So this I think he might know it, but that 1 hour session with him actually changed me. So just like you, doctor, he was an IR, so that's why I inspired to be like him. He was an IR. I was doing my internship in Petronas Penapisan Melaka.
Okay.
So that time, just like any other supervisor, he will test you. Okay, why this process like this? Then you try to answer lah, and then why this process like this? Try to answer, and then he will come to like, oh, he got more advanced. I want to give this message to the other students how it changed me. So okay, and then he start to ask the detailed question, and then I say like, oh, I don't remember, even though I already learned. It's actually the thermodynamics, the fluid mechanics. We already learned, but then we don't remember. So just like, why don't you remember? It's like you already learned. Like, maybe that time because I was a student, I just study for fun only. I like study, I finish exam, forgot lah. Exam, learn, forget. Then why you want to become engineer? By the time you graduate, you don't remember anything. Then why are you different from the other engineer? Just like, then I said, quick quiet up. It's like he start to get serious already. It's like, then the keyword will be, why is your appreciation on the knowledge that you learn? Why you never apply your knowledge? You can learn many things, but then there are others who is very eager to learn what you learn and will appreciate more than you learn, because you learn and then you forget, even though that can actually go to others. Then like, okay, then start to appreciate knowledge. But how are you going to appreciate the knowledge? You appreciate the knowledge is like when you learn, you try to apply to your everyday life. It's like it can be a simple thing like water. You start to learn more in that way. You learn about the polarity, you learn about the precipitation, everything, and then you start to try to relate with life. Why is a bubble in sphere? It can be due to the why is a water droplet sphere? Why can this thing? It's like, oh, actually all goes into one answer. Is just the surface tension. Why is a water a universal solvent? It's actually have to do with the polarity. So it's like when you start to relate, you start to see the bigger picture. It's like you see the connection, and then you start to see that, oh, your learning is interesting, and then you start to learn by experience. You experience that, and you get interested in it. So that's when you appreciate the knowledge. You start to apply your knowledge to your everyday life. If you see like this, or when you have the answer, you see like this, or you already know the answer like this. So it start to become more interesting. You start to become, you want to learn more and more and more. So that session with me is it changed me immediately, in the sense that the next semester is the semester 7 and 8. I actually learn because for the first time I learn because I want to learn. Before this is like I for my first 3 years just like I learned because I was placed in chemical engineering degree. Maybe it's because my pointer, right? I got the chemical engineering. Then I just learned. After that I forgot. It's like for fun. I never have really a career goal. I want to become an engineer. But on the 4th year, it's just like I learned for the sake because I want to learn. I want to understand why this works. So it's like my pointer is like wow, very high.
Okay, so you improve your pointer rapidly at the 4th year, right?
My pointer is very different because for the first time I learn because I want to learn. Because for me it's that I start to build the interest in me to learn chemical engineering, and then when I finish my degree, I just like now I want to continue my master. But then not yet lah. I mean I have another commitment, but in the future I want to continue my master because for the sake that I want to learn.
But okay, let me tell you something. Okay, I know that you just informed to me unofficially that you have the desire to do masters, but you are actually now a very considered successful engineer, practicing engineer, and you are already having the plan of getting some certifications that are very, very crucially important. So I think my suggestion is you carry on to pursue what you are planning to do. Okay. A master's degree is just another certificate, but having that certificate maybe is going to be a little bit different from the actual experiences that you are having now. Okay, unless if you want, you can do both at the same time, meaning you still keep on working and then you do masters part time. So that's another plan.
Also, not the research one. The research is like we will consume my time, but the coursework one is where I'm being teach. I learn new knowledge. I can hopefully learn, improve myself.
Okay, this is very important question. What are the important skill that an engineer need?
First is your process knowledge.
Okay.
Your process knowledge, because you engineers is like at the workplace. Engineer is actually quite an authority figure at the top. You will always make decision under your boss lah, under the manager. But normally the manager also come from the engineer's line. So the important skill will be about being a yes man. One thing, always think. Every step, think, and then everything that you do, learn something from it.
Okay, wait. Okay, I want to stop you there. When you say think, can we relate that to critical thinking?
Yes, critical thinking.
Okay, and then when you say think, and then I adjust a little bit to be critical thinking, and then you say you think, and then what can you do after that? So the next thing is maybe reflective thinking or reflective learning.
Will be reflective thinking first. After that,
reflective thinking. Okay.
And you learn when you're already done, then you reflect what you learn and try to apply. Just one example. Okay. One of my tasks that time is still during my first year that time. Again by my boss, the garang one.
Okay.
So there's a sulfuric acid tank. This is actually a repetitive problem for few years already. So we have a tank. So when the tank is being used in the process, the sulfuric acid, there we have to top up. The supplier will come with the tanker, load the sulfuric acid to the tank, and then they load using the hose. So every time they load, because of course they're going to be a spillage, everything, right? So every time the spillage will go to drain, all the drain in the complex will drop to pH 1, and that is a very big environment issue. Have been going on for a few years, unsolved. So my boss take the initiative. He don't want keep having this headache, so he wants to solve the problem. So what that time the bosses and the other engineers think was like, oh, they're going to change this whole area into a containment area, which is any chemical that goes inside this area will be contained, neutralized, and discharged. So you will solve the problem. But and then he purposely challenged me if I can give a better solution. So that time I just see that the problem, when I start to see the problem, it's just like this problem is actually very simple. You transfer to the tank and then you have a spillage. Where the spillage come from? It's actually from the hose. And after you transfer, of course, you want to keep your hose, you will throw away the exit inside, you keep your hose. So when I know the root cause already is the hose. So what my solution that time was, when their solution was to make the containment dye. That time the price, the budgetary price was around more than 100k to have the chemical layer. So my solution that I come out with is only 3,000 ringgit. So my solution would be, if the hose is the problem, I tackle the hose, the root cause. So what I do that time is like, instead of the tanker come with their hose, unload and then flush the hose, keep back with them, I say you don't need to bring the hose. The hose put inside, the hose will be supplied by me, and I put a check valve at the hose, so that whenever you start to fill in, now your salvation goes inside the hose. There's a check valve. It's a one-way valve, non-return valve. So it's like after you have finished loading at the start, I have a narrator, so that means the hose or the separation inside cannot go out. So that, okay, you push the support, you go out lah. Now the separation inside the hose is trapped inside. The separation is trapped inside the hose. And tomorrow you come load, you just flush the hose. Yeah. So that solution is only install one small valve for two area, and the cost is only 3,000 ringgit. I actually solved the problem that they're going to spend more than 100,000. Just
That's a good solution. Yes. What was the diameter of the hose?
It was a 3-inch.
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 Okay. All right. Okay. So you is it a quick coupling connection?
Yes, it's a quick coupling type. It's a custom one. The quick coupling, right at the flange of the quick coupling is a one-way valve. That's
Okay.
all. That's the solution.
Bagus.
I think that one is considered a critical thinking. And
Yes.
then actually I got the idea was because that time it's driving problem, and then I'm watching a Formula One. And then when they go to the pit stop, how they refill the technical part like that, very quick they pull out. So that is, it triggers me. Why can't we do the same at the separate exit plant?
Okay. Yes.
Come from anywhere. Just that how are you going to relate it? And then that is like thinking out about that. The inspiration can come from anywhere.
Okay. That's good. So just now you have several, which is the critical thinking, and then reflective thinking, and any other skills, perhaps that maybe you want to mention?
No, it's just think out of the box.
Okay. Think out of the box. Okay.
It's always think, always see how can you improve it. Because the value of engineer is you solving the problem, you come up with the problem. It's come up with the solution.
Okay. Thanks for that. I think those who are listening should really consider and think about this. What you have just said. Okay. What else? Okay. So I think I'm reaching to the end of the question. What are the advices that you can give to the chemical engineering students or young engineers, or maybe those who are actually in their secondary school or matriculation, STPM or so on, A levels? Maybe they wanted to be a chemical engineer, but maybe they need some direction or some advice. Maybe you want to say something?
My advice to them will be what I received from my supervisor: appreciate the knowledge.
Okay, appreciate the knowledge. Okay.
The knowledge, if you're interested, then put on interest, and then you will see that actually chemical engineering covers many fields. When you learn chemical engineering, you apply your thought process, you can actually see the world in a bigger picture. When you see the bigger picture, it's easy for you to grasp the idea of what's going on, what needs to be done. It helps you in your life also.
Okay, fantastic. Okay, I think thank you very much, Haseeb. So it has been a very relatively long but fruitful session. So I hope the rest will learn from this interview. Actually, this is like a sharing. So it's me asking you questions and then you giving feedback. So I also learned something from you. So it's very interesting, and thanks a lot for sharing. Okay, Haseeb, thank you very much. Assalamualaikum. Good night. Good evening.